Okay, so next I've just documented some ways that you can use technology to find or calculate our descriptive, or we also call that summary statistics. So I've outlined how you could use the TI-84 calculator if you have one. Again, I want to remind you, you don't have to get one of those for this class, but if you did have one and you wanted to know how to do it, this would be the steps that you would go through. Okay, in StatCrunch, which I demonstrated in our last video on the Menace soccer players and fans, if you didn't see that, I would say go back and definitely watch the last 2 minutes of that. I also included another video on our Blackboard course on how to use StatCrunch to calculate summary statistics, but just shortcut here, this would be the approach you would take to using StatCrunch for summary statistics. Okay, so the next thing I want to do is go ahead and take a look at something called coefficient of variation. And this is yet another way that we can talk about or calculate or examine how disperse our data is. So far we've talked about standard deviation and variance. Both of those are measures of variation. Coefficient of variation is yet another thing that we can use. Okay, so it measures how disperse our data is. This is good to use when you are looking at two different data sets and comparing them, but they have very different means, and so their standard deviations are going to be quite different as well, possibly. So each of those standard deviations would be relative to a very different mean or data set. So we use something different. We are going to be looking at the ratio of a standard deviation divided by its mean for a data set. If we were looking at population, we'd be looking at the population standard deviation divided by its mean, and then multiplying by 100 or moving the decimal over 2 places to identify this as a percentage. So basically it's just describes the standard deviation relative to the mean, and it's going to be expressed as a percentage. So again, we're going to use this when you have two data sets with very different means. So here I've got a sample of 15 women. We're going to use technology to calculate the mean and standard deviation for these women's age as well as their weight. Now, of course, because these are two different criterion, age and weight, their means are going to be very, very different. So for sure, we're going to be using our coefficient of variation. So in this scenario, I've already gone in to StatCrunch and calculated the age and used the age and the weight data here to calculate the mean and the standard deviation for both age and weight. We came up with a mean of 24.3 and a standard deviation of 8.2 for the age. In other words, each data piece here varies from the average age of 24.3 by about 8 years, typically. Okay, so in our weight, we have an average of 145.3 pounds with a standard deviation of 29.4, which means that the typical data value varies from the mean by a little bit less than 30 pounds. That's basically how you can interpret standard deviation. So for our coefficient of variation for age, we're going to take the mean divide by, the standard deviation divided by the mean. We come up with 0.337 written as a decimal, moving that over 2 places to write it as a percent, is 33.7%. Our coefficient of variation for weight, we're going to take our standard deviation of 29.4 divided by the 145.3. We come up with 0.202, move that decimal over 2 places to write this as a percent, and we have 20.2%. So again, I've kind of written up here that the higher percentage means more dispersion. So when I'm looking at this, we've got more dispersion among our age than we do our weight. Our weight is less dispersed for this data set. Our age is more dispersed. Now I wanted to show you how you could do all of this in StatCrunch all at once. So I've listed the ages and I've listed the weights here. I want to go into stats. I'm going to use summary stats again, and I'm going to use columns. But this time I want to look at the ages and the weights. So I'm going to click on ages to move that over to my active column, but I'm also holding down Control to move over weights because I'm going to do both of these at the same time. The other thing that I want you to see is down here as to what I want StatCrunch to do. It's going to calculate all this standardized stuff, and I would just leave it at that because we're going to use that definitely toward the tail end of this chapter. So definitely just leave all that extra stuff in there for now. But I also want to do this coefficient of variation, so we can get StatCrunch to do that for us as well. But again, hold down the control, click on the coefficient of variation, and then I need to move this up here so that we can click compute. And it does that same chart as it did before. It provided us our mean for both of our age and our weight, so that column there was pertinent. Our standard deviation, which was 8.24, that's how I got it for that problem, and then 29.3 for the weights. But over here at the end, it also calculated our coefficient of variation for each of these as well. So you can use StatCrunch to do some of that calculating for us as well. I also wanted to point out all this other stuff here we are going to use in section 3 of this chapter, most of this other stuff, but you can see that StatCrunch also calculates the mean for us.